our job now is to repeat the process of finding a secant line by using the point C and the point A versus the point A and the point B down here. So A and C are going to give a better approximation of the actual tangent through a better secant line. So what do we need to do? Well, the first thing we need to do is find the slope between A and C. So our slope, our m value, is equal to the difference in the y values. So I went 3 minus 1.75. So now I have to go 1 minus 1.5. So on the bottom, I'll get a negative 0.5, and on the top, I'm going to get a 1.25. And so if we take 1.25 and we divide it by negative 0.5, I'm going to get negative 2.50. So my slope is negative 2.5, which means that to get from point A to point C, I've got to go down negative 2.5 over 1, right? So that also means that I must go down negative 1.25 over a half. That's what this is right here. So we have our m value. Now what we'll do is we'll get our b value. So y is equal to mx plus b. Our m value goes in here. And now what we'll do is we'll take one of our points, doesn't matter which one, probably easiest to grab the point A. We'll plug in 3 for the y value, 1 for the x value, and we'll solve this. So our intercept value is 5.5. When you do your problems, just check to see if that actually makes sense. You know, does the answer that you get out, does it correspond with what you would see on the graph here? And of course, we saw that last time from A to B, the intercept was up here at 6. So clearly, the slope between A and C is a little bit less steep, so it should have a little bit less height on it. So 5.5 makes sense. And we'll go ahead and we'll check it out, graphing it as well. So we believe that this guy over here is our secant line, what we're going to call secant 2. So if I draw that guy in, there he is. And so this guy is secant 2. Now secant 2 is a better approximation for the tangent line that we're drawing. There's the tangent line. Then was the original secant line. So secant line 1 looks something like that. So the black one down here is secant 1. The red one is secant 2, and the green one is the actual tangent. Now we'll go ahead and we'll use a program to verify that that's correct. So let's go ahead here and grab Desmos. Okay, and let's pull that a little bit more into range. So we want negative 2.5x plus 5.5. Notice that it does look like it passes through those 2 points. If we want to, we can zoom in a little bit more. And we might be able to zoom in just a little bit more. There we go. Okay, now if we zoom out, we can tell, just what I was saying before, we can tell that the last secant line that we had, this is the secant line that runs through, let's mark this guy up right here. Okay, so what I've got is this line, let's make it not red anymore, let's make it purple. There, orange, I like orange. Okay, so the orange line, okay, is a better approximation than the blue line to the actual tangent, which we have as negative 2x plus 5, the green line. So let's look here. the green line is the actual tangent value. Let's icon these guys off. Okay, so the green line is the actual tangent. This was the first estimate. It's okay, but now if we take that away, we put in the second estimate. That's better. So notice the difference. Notice how as I go from blue to orange, I'm getting closer to this green value. That's the idea. So we need to keep picking secant values that are closer and closer.